Okay, so today we are going to talk about shifting quadratics using the equation to do so. And if you recall exponential growth and decay functions, we had an h and a k. Remember that h shifted left and right, k shifted up and down, but h lies and k tells the truth. So when we had, for instance, x minus 2, this actually shifted right 2, even though it looks like it would shift left 2. K tells the truth, so if we had minus 2 off at the end, this would truly shift down 2. So, example number 1, determine whether the function is reflected, then describe any shifts. Well, first let's reflect on what reflected means. If the number out front is negative, then it is going to be reflected across the x-axis. If it is positive, it is not reflected. Okay, so A, we have y equals negative 3 to the power of x plus 2 plus 4. It is reflected because of the negative. And now let's look at the shifts. H is with the x because we have x minus h. Okay, so we have x plus 2. Looks like it would go to the right, but it's actually going to go to the left. So we're going to go left 2. And then k is off at the end here. But k tells the truth, so if it looks like it's going to go up 4, it really is. So we're going to go up 4. Example B is also reflected because of the negative. And let's look at h and k. Now there's nothing added or subtracted from x, which means that h is 0. So we are not shifting left and right. The only thing we're going to shift is down 3 because k is negative here. Okay, so let's take what we know and look at quadratics. Notice that h is still with the x and k is still off at the end. H still shifts left and right and lies. K still shifts up and down and tells the truth. So, determine whether the function is reflected, then describe any shifts. Again, in example A, this is reflected because of the negative. Here we've got x minus 3, that's h, but it lies, so it looks like it's going to go left 3, but we're really going to go right 3. K is off at the end here, and it tells the truth, so plus 1 means up 1. Example B is positive out front here, and so we are not reflected. We're going to look at h. H is with the x. It's x minus 2, which would imply left, but it lies. So we're actually going to go right 2. And then there's nothing for k, so we could really say plus 0. That means that it's not going to shift up or down. C. It is positive out front, so it is not reflected. There is nothing added or subtracted to x. That means that h is 0. That means that the graph is not going to shift from left to right. However, we do have a k off at the end here. It's minus 5, so we're going to shift down 5. You are now responsible for the checkpoints 1 through 10.